So after you finish downloading your virtualization software, and I have VirtualBox here, and your VM, then you just navigate to where your VM is located, and then you double click here on the Quick Start, and that's going to open this VM in VirtualBox. And you're going to go ahead and review the settings. So let's take a look and make sure that we have the appropriate capacity on our machine for the defaults in this VM. So it's a 64-bit, 1 CPU. It's using 4 gigs of RAM, so it's a pretty significant amount of RAM. And the rest of the settings look okay. So I'm going to say import. And now my machine is successfully imported. So I'm going to go ahead and click Start. And I have to unblock some features of the Windows firewall. And you can see now you have your virtual machine, and I'll go ahead and open the terminal, and I'll type in Hadoop version, and you'll see that we're working with Hadoop version 2.5.0. After you set up your Hadoop development environment, you might want to consider adding other Hadoop libraries. Most of the time you'll be adding these core libraries, and if you're getting a vendor distribution, they'll usually be included. But if you're getting the plain vanilla open source distribution, you'll have to remember to add them. So we usually want to add Hive, which gives you the ability to have SQL-like or HQL query, and that creates batch mapreduce jobs with that query. The pig library, which is an ETL or an extract, transform, and load like scripting language that allows you to do ETL type of tasks. Data manipulation, for example, stripping, trimming, joining, that kind of stuff. And another common library that is frequently used is Impala. And this, like Hive, lets you use SQL-like queries, but unlike Hive, rather than creating batch processes, it's an interactive process that makes use of the memory in the machine. And we'll be looking at this in more detail as we get into the intricacies of MapReduce. In addition to the core libraries, certain business users will have use for some of the many other available Hadoop libraries. And I just pulled out a sampling of ones that I have worked with here. The first one is Mahout, or Mahout, depends on who you talk to and how you pronounce it. And this is a library of machine learning algorithms, or predictive analytics, or data mining, if you will. Things like clustering and time series and decision trees. It's a very rich library that's used by analysts and statisticians. Two of the newer libraries that are causing a lot of interest are Spark and Storm. They're very complex, and I'll be addressing them in more detail in a subsequent movie, but both of them have to do with in-memory streaming or processing. At a high level, the difference between Spark and Storm is Storm is designed for complex event processing, and Spark is designed for in-memory processing of resilient distributed data sets. Soon we'll be ready to write our first MapReduce job. So we need to decide a couple more things before we can do that. We need to pick our programming language and also our development environment. So I'm going to be showing the majority of the samples in Java, which also requires installation of the JDK. It is also common to have MapReduce jobs written in other OOP or programming languages. One example is Python. And increasingly, we're seeing bridges between data-centric languages like the R language, which is a statistical language, and is more frequently being used as there's interesting implementations of Hadoop data scenarios. Now, in order to work with these programming languages, although you could use a text editor, I prefer to use an IDE. So the IDE that I'll be working with primarily is Eclipse for Java, and you'll see that in the virtual machine. Now, Cloudera's virtual machine does include an Eclipse installation. Not all of the virtual machines do that. So Eclipse, of course, is open source. So when you're setting up your environment, whether it's in a virtual machine or on-prem, you will probably want to have some kind of editor. You can use a text editor, but it's just a lot more efficient to use a more fully featured editor, especially if you're going to work with Java. Now, when I'm working with Python, I just prefer Sublime, so I might be showing that in some of the samples as well. And then when I work with R, I work with RStudio. So I've maximized the virtual machine that we downloaded from Cloudera. And this is a Linux box running CentOS. It's running in VirtualBox on my Windows machine, but because we're going to be working with this to take a look at MapReduce jobs, write them, execute them, and debug them, and I've made it full screen. So let's go ahead and take a look at what we've got here. So first we have the Cloudera home folder, and you can see there's a whole bunch of samples that we'll be working with. In particular, take note of the data sets. And you'll notice the format of the data sets is in text and something called .sh. We've got some zip files around zip codes, and then we have some SQL code to set up some tables for Hive. And this is a pretty standard file system. If we click up here, this is the terminal, and I showed you this at the end of the last movie, but again, I'll just run a Hadoop command, and you can see this is a common way to interact with the Hadoop installation that we're working with. So I had shown you the version, which was 2.5, and you can see information about Hadoop here. And it's very common when you're interacting with Hadoop that you'll use the terminal. So in addition to that, we are going to be working with the Eclipse IDE, and Cloudera was very nice in installing this for us. So I'm going to go ahead and open this up. This is the Juno edition of Eclipse, and they've also included some sample files that we'll be starting with around mapreduce. And they've referenced the core libraries and some optional libraries. You can see that the workspace that we're working with here is the training workspace. And if we look at the referenced libraries, we have a number of Hadoop libraries, which include mapreduce 2.0. And a quick way that you can tell that is we've got the yarn libraries, which again stands for yet another resource negotiator. In addition to that, we have some optional libraries like Zookeeper, and one that I hadn't mentioned up to this point, mrunit, which is an extension to JUnit, and allows you to do unit testing against your MapReduce code, which is very, very useful. So we'll be working in this environment quite extensively, and if you have a setup and you want to follow along with the exercises, you are going to want to bring down Eclipse and bring these libraries in as well. Now, in addition to Eclipse, I'm going to open up Firefox. And there are a number of browser tools that are of use to us. You might remember from an earlier movie, I showed you Cloudera Live with the Hue browser. And again, you have that same configuration here with that same set of samples. You install the examples, which I did. And you can see the same thing. That's why I recommended that you start there. Now, in addition to these samples, we have some browser-based utilities to interact with core Hadoop as well as some of the libraries. So let me show you what those look like. So core Hadoop, we have a number of JVMs or Java daemons, and those are around the functionality for the cluster. Again, this is a single node, so we're running in pseudo-distributed here, which you might remember means that we have HDFS with all the daemons running on the same node. So for example, we can take a look at the name node. It's going to give us information about it here in the browser. We could also see if we were in actual distributed mode, if we had live or dead nodes or decommissioned nodes, because you may remember the idea, of course, of Hadoop is that you can massively distribute this across commodity hardware. So it's really common that you'll see numbers in the hundreds or even thousands or tens of thousands in the number of nodes. We also have the secondary name node. And this was in addition to Hadoop around version 2.0, and the idea is for higher availability because the name node is an indexer to all of the different information stored in the Hadoop system. So as you might imagine, if the main name node were to go down, then you would have a complete system failure. So it was really demanded by the Hadoop user community to add this high availability secondary name node option. Now, in addition to the name node and secondary name node, you've got the data node. Of course, we only have a single data node here because we are in pseudo-distributed. Again, in a production environment, you'd have hundreds, thousands, or even tens of thousands of data nodes that would be viewable here. Now, in addition to this, because we're in Hadoop 2.0, we've got the Yarn Resource Manager and the Yarn Node Manager. These are replacements for what was called the Job Manager and the Job Tracker in Hadoop 1.0, and they add a level of sophistication that Hadoop customers were looking for. We'll be getting into that more as we progress along through the course. Now, in addition to information about core Hadoop, we have information about HBase, which you might remember is a library. And this allows you to do SQL-like queries, which generate MapReduce jobs. So we have high-level information about HBase here. In addition to HBase, we can see that we have some other libraries installed. I mentioned in a previous movie that a newer library is called Impala. This is specific to the Cloudera implementation, and it's an implementation of in-memory querying, which allows for a more interactive query experience, less batch-like and quicker, if you will. So there's been a lot of interest in the community in this. Spark, as I mentioned in a previous movie, has to do also with in-memory. So you can see there's kind of a trend around libraries in the Hadoop ecosystem to move some or all of the data into memory to speed up the processing. And this is something I have seen quite frequently out in the real world working with actual Hadoop customers. And there's some other libraries here as well. If you have a virtual machine with 8 gigs or greater of RAM, Cloudera gives you the option to work with the Cloudera Manager. Because that's more focused on administrative tasks, we're not going to be focusing on that in this course.